Hey, so the thing we spent the most time on in Algebra 2 was quadratics. And remember, quadratic, we hate them, but there's so much we can do with them, but they're actually really easy, and once you get back into it, you'll really remember everything. But a quadratic formula is anything where you have like x squared minus 3x plus 2, something like that. And the first thing you always want to think about is, can I factor it? So let's remind ourselves about what all these things mean. So we can always assume that it equals 0 if we're trying to find the root, which is the same thing as the x value, which is the same thing as the 0, which is the same thing as the solution, because of course it is. And remember, this always stands for a parabola. Okay, so it's going to, and parabolas are either going to be looking like this, or they're going to be looking like this. And this, it's going to be face up, like a happy face, if the x is positive, and if the x is negative at the front, then it's going to be a sad face. Okay, so in order to figure out what the all these things are, you have to factor this. So if it's factorable, remember, you do the thing where you're like, let's do this, and you think, what do we multiply to make 2 that would add to give us 3, and in this case a negative 3. So we take the square root of this, so that's x and x, so x times x is going to give us x squared, and then the only factors for 2 are 1 and 2, so hopefully those are going to work out. So if those two multiply, we get 2. If we have 2 negatives, and then we FOIL to check our work, we get x squared minus 2x minus 1x plus 2, and then that is x squared minus 3x plus 2. So that's factoring. Easy peasy lemon squeezy, right? Cool. Remember, there's other ways to solve for, so that means that the solutions, or the roots, or the zeros, or the x values, whatever you want to call them, can be found doing x minus 1 equals 0, and x minus 2 equals 0, and then solving for x. So that's just taking each one of these and setting it equal to 0. Okay, so then the solutions are x equals 1 and x equals 2, which means up here in our graph we can say, okay, at x equals 1, it's going to cross the x-axis, at x equals 2, it's going to cross the x-axis. We know it's going to face up, we know it's going to cross here and here. We don't know how far down it goes yet because we have to solve for the vertex. And remember, there's a couple different ways to solve for the vertex. One way is to let's talk about the quadratic formula first. So remember the quadratic formula, which is another thing we spent a long time on, and you're going to remember it, and it's going to be like, oh my god, I can't remember, I forgot that. I can't believe I forgot that, it was so easy. So the quadratic formula is another way to solve for your roots, which you're going to get from it are your x values. We're going to use this same equation because why not? And so remember, the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a, where let me write that formula here. We have x squared minus 3x plus 2. This is a, this is b, and this is c. So a is 1 in this case, b is negative 3, and c is 2. So if we rewrite the quadratic formula, negative 3. Okay, so there's our negative b plus or minus the square root of b squared. So negative 3 squared is 9, minus 4ac. So 4 times a, which is 1, times 2. So that's 8. 4ac. So 4ac is going to be 4 times 1 times 2. So that's 8. All over 2a, so 2 times 1, 2. Alright, cool. So we get x equals negative 3 is positive 3 plus or minus the square root of 1 over 2. And then because there's the plus or minus, we have to split it into two sides. So we get 3 plus the square root of 1 over 2, and 3 minus the square root of 1 over 2. So 3 plus 1 over 2, so 4 over 2 is 2. 3 minus 1 is 2 over 2 is 1. And look at that, we got the same answers. X equals 2 and 1. That's a comma. Whoop. All right, cool. So that's the quadratic formula. Now to solve for the vertex, so the vertex is the point in which our graph is going to turn, and the vertex is given, and you may or may not remember this from conics. It's not super important if you don't, but the point is given as h comma k, and we're going to solve for h and then plug in to get k. So let's do that over here. So we get h, and the formula for h is negative let me make sure I'm not lying, negative b over 2a. So it's kind of like part of the quadratic formula, just not including the everything underneath the square root. So negative b over 2a for ours was negative 3 over 2 times 1. So 3 over 2. So h is 3 over 2, or 1/2. So that's going to be the x coordinate for the vertex. Cool. So now where's the y coordinate? The y coordinate is given as k, and we just plug it into our original formula. So k, using x as 1.5. You might also see this, so if we, let me think about this. A lot of times we talked about our formulas in terms of y equals x squared minus 3x plus 2. But you can also write that as the function of x equals x squared minus 3x plus 2. These two are the same thing, but this is a fancier way to say it. And anytime you say, it says, and then solve for or find f of 1.5. That just means whatever was here, you replace with whatever is here, right? So where this was originally x, we're going to replace it with 1.5. Okay? So then you have 1.5 squared minus 3 times 1.5 plus 2. And we math that up. Okay, so let's math this up. Remember, when in doubt, use your calculator. So 1.5 squared minus 3 times 1.5, oops, plus 2. So negative 0.25, or negative 1/4. Okay, equals negative 0.25. So our vertex is at 1.5 comma negative 0.25, which means up here on our graph we know where it crosses. Now we know that it's going to be, so remember this was 1 and 2, so 1.5 is right in the middle, and then if this is negative 1, then maybe 0.25 is right there, so then our vertex just goes like floop, floop, like that. Done and done. Because who cares? I mean, we technically care, but not really where the rest of it is. You could solve for the y value by just plugging in 0 for x, and you'd find, oh, that's 0, it's 2. So then you get 1, 2, so really it should go like that if you want to be super fancy. Yep, so what did we do? We just figured out how to do zeros, or x values. We figured out how to find the vertex. We figured out how to find out if it's positive or negative, and we kind of reviewed factoring. Let me give you another one to practice for factoring. Let's look at here we go. So if you have x squared plus 6x plus 8, how would you factor that? So if I asked you to, so if this was y equals, and then solve for x, what would you find? So let's do some Dora the Explorer stuff. Why don't you pause and try it yourself? I know you will, and then just hit start again. Okay, so what you should have done, which I'm assuming you did, is you'd say, okay, so the only thing that you can multiply x by to get x squared is another x. And then if we have 8, we have to say, okay, the factors are 1 and 8, 2 and 4, and that's it. So these two will add up to 6, so that means this is plus 2, plus 4, and so and then we solve for x. Let me not skip steps. So x plus 2 equals 0, so x is negative 2, and x plus 4 equals 0, x is negative 4. So those are your two answers for this. I also could have asked you to find the roots of this equation or the zeros of this equation, and you'd get, it all just means solve for x, and that just means factor. Okay, so factoring sucks a little bit when you have a non-1 for an integer at the beginning of your equation. So what that means is if I have 3x squared plus 5x plus 2 and I ask you to factor it, there's different ways you could do it. There's the thing where you make the box and you're like, oh, okay, so if that's 3x squared and that's 2, I need to figure out my two factors. I could never do it that way, so I do the umbrella method. I know this way works for a lot of people, but what I taught you guys in class, and one way that really works for me is the umbrella method. So you make a little umbrella, and then you take a from your equation, that 3, and you make, so if you do your parentheses, 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 okay, you put 3 at the beginning of each one. You actually put 3x, 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 and then just 3. Next, you're going to multiply a times c. So a is 3, c is 2, so 3 times 2 is 6. Now you have to say, what are the factors of 6 that will add to 6? Okay, so bear with me. So we've got 1 and 6, that does not add to 6, that adds to 7. We have 2 and 3, that is 5. Oh wait, that doesn't add 6, sorry, it adds to our middle number. There it is, right there, 2 and 3. Cool, so we are going to, okay, everything's positive, so that's going to be, it doesn't matter where we put them right now, because we're going to do some simplifying. Okay, so I'm going to put a 2 here, I'm going to put a plus 3 here. Now, always remember to simplify as much as possible. So can I simplify 3x plus 2? No. So I'm just going to leave it like it is. 3x plus 2. Can I simplify 3x plus 3? Yes, I could. Remember, this means there's a multiplication sign there. I could pull a 3 out of this because I could divide both of these two by 3. Awesome. And then I'd get x plus 1. And it's all still over 3. So now I have this factor, a 3, this factor, and it's over 3, which means these 3's cancel. So if I have one on the top, one on the bottom, I can just make them go away. They just cancel each other out. And so then my roots become 3x plus 2, x plus 1, and then just solve for 0. So 3x plus 2 equals 0. So x will be negative 2 over 3. And then x plus 1 equals 0. X is negative 1. So let's do another. Let's do 10x squared plus 13x minus 30. All right, so again, first step, make your umbrella. There we go. I'm going to do 10x, 10x, 10. Whoops, almost made that an x. So there's 10. Now I'm going to do 10 times negative 30. 10 times 30 is 300. Well, and remember that's a negative, so it's going to be negative 300. So now I need to figure out what factors of 300 will add up to 13. Okay, so my factors are 1 and 300. This could go on for a while. 2 and 150. That sucks. Let's try, well, we know 10 and 30 are up there, but they're not going to add to 13, so that's no good. What else can we divide 300 by? How about 5 and 60? Well, that's not going to work. What about 15 and 20? We're getting closer, but these will, remember, one of them is going to have to be negative to get us a negative 300, so these will subtract to 5. We're almost there. How about 12 and 25? That does work. If one of these is negative, we'll get a 13. So if we make 12 negative, and then we add these together, we get positive 13. So now, again, it doesn't matter where I put them. I'm going to do 12, and then I'm going to do 25, and now I have to simplify. So can I pull anything out of this? Yes, I can pull out a 2, so 2, and we get 5x minus 6. And then can I pull anything out of this? Yeah, I can pull out a 5, so times 5, and look, we get a 2x plus 5. Oh look, 2 times 5 equals 10, which it's over, and that's the goal, is to make something pull out of these two so that you can cancel with this. Cancel, 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 because 2 times 5, 10, and you get 5x minus 6 times 2x plus 5, and then set those equal to 0, and then 2x plus 5 equals 0, so x is going to be 6 over 5, and negative 5 over 2. Oops. Sorry, so there are the roots, or the x values, or the zeros of that equation. Easy peasy. Sort of. It is a couple steps, but it isn't the end of the world. It's easy-ish. All right, one more for you to do. And then, let's do 3x squared plus 13x plus 4, and hit pause. Oop, you can't see it. Okay, hit pause and solve it, and then come back. So we were going to make our umbrella method. 3x over 3. 3 times 4 is 12. What factors of 12 will add to 13? 1 and 12. So plus 1 plus 12. Okay, nothing's going to come out of this, so that's going to stay as it is. 3x plus 1. But I can divide these both by 3. X plus 4. Divide that 3 is still there. Whoop, those go away. You get 3x plus 1. X plus 4 is your answer. And now we can solve for the roots. So x is going to be negative 1/3. And then x plus 4 equals 0. X is negative 4. And those are your answers. Now another thing we did with quadratics was we talked about completing the square, which is where you have something like x squared plus 4x equals 0, and you're asked to complete the square. Complete the square. And the reasoning behind this was so we could find the vertex and then blah blah blah, do conics. But just to remind you how to do this, what you do for this, remember if this is A and this is B, we don't have a C, we're trying to find C. So to find C, it's B over 2 squared. Okay, so you're going to do, for this one, it's going to be 4 divided by 2 squared, which is 2 squared, which is 4. So this is a bad example because it's going to be the same thing. But basically what that means now is you're going to add whatever this is on both sides. So you're going to say plus 4, because if you have that equal sign, you can't do something to this side without doing the same thing to this side. Okay, so now our equation is x squared plus 4x plus 4 equals 4. And by definition, because we completed the square, this is now x squared plus whatever the thing inside here was, 2 squared. Sorry, not x squared, just x plus 2 squared equals 4. So now what we can do is we can solve for x by taking the square root of both sides. Pew, pew. So x, this whole thing squared, the square root's going to cancel out that square. You get x plus 2. This is now going to become plus or minus 2. Okay, oh, there's my cat. Okay, back off, kitty. This is not your math. We're not completing the moon. Okay, cool. So now we can split this into 2 equations. So you get x plus 2 equals 2. X plus 2 equals negative 2, and then solve for x. It's minus 2, minus 2, minus 2, minus 2. So x equals 0, and x equals negative 4. Okay, so if that went a little fast, let me give you another one. It is not going to be, oh, Mooney, silly cat. The cat is trying to make sure you learn your math by getting in the way of everything. There she is. She's a giant. Mooney, Mooney. Yeah, there she is. She's terrifying, and the queen of the world, so she thinks. All right, let me find you another problem. All right, look at x squared plus 7 equals, or sorry, plus 7x equals 0. Let's not even solve for x. Let's just figure out how would you complete the square here. So you would have to say, okay, so C, what we're looking for, Moon, back off, is 7 divided by 2 squared, which is a gross number, but it's fine. It's all good. So then you're going to have, so that's 3.5 squared, or you can just say, okay, that is 7 squared, 49, over 2 squared, which is 4. So we're going to be adding that to both sides. So x squared plus 7x plus 49 over 4 equals 49 over 4, and you've completed the square. That's good enough for me. So remember that the reason why we have these quadratic formulas sometimes is to solve problems that involve, well, actually you may not know this yet if you're not in physics, but we use it in physics to solve gravity problems. So the idea being you throw something in the air, then it's going to come back down. So you might be asked, given the equation, it'll say something like h equals negative 3t squared plus 80t. Yeah, we'll just do that. When does it hit the earth again? So when you have problems like that, like word problems that are all blah, 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 but you're still given this quadratic equation, it's talking about something hitting the ground, you're just solving for 0. You're finding your factors again. So you're finding your factors. Okay, so, or just solving for 0, or solve for t, that's what I mean. Solve for t, which is basically x in this situation. Cool, so if it makes you feel better, you can even change them to x's. So if we make this 0 equals negative 3x squared plus 80x, oh, that's an x, sure. That's a 0. So let's just solve for x. So we're going to get, so we can divide both of these by x at first. So we get 0 equals x, 3x plus 80. Cool, now we just solve both of these, set these equal to 0, so x is 0, and then so that one's gone, and then we do 3x plus 80 equals 0, so 3x equals negative 80. Oh, that's negative, I forgot about that. Divide both by negative 3, and then whatever that is your answer. So negative, that one's not negative, is negative 80 over 3, or negative 80 over 3, same thing. And that's the answer. So you're just solving for x in both of these situations. In this situation, whenever it says, what time will it hit the ground? Just solve for x or solve for t. One of the factors is going to be 0, so that's when it's thrown in the air at the first time. The next one is going to be when it hits the ground again. Oh, wait, no, this is negative, isn't it? Oh, that's me losing my negatives. So then those cancel out, and you just get positive, positive, which makes sense because time has to be positive. Now you might see some things where it says solve for x, and it has part of the equation in, well, first of all, if you see something like this, how do you square this? And you might freak out first because you'll just see an exponent, oh no, and I'm going to have to square, you just FOIL it like normal, so x squared minus 2, x squared minus 2, and then if we FOIL, we get x squared times x squared. Remember, if you have x squared times x squared, these two really just add, so you end up with x to the 4th. Then we have x squared times negative 2x, so minus 2x. Negative 2 times, 2x squared, sorry, boom. And then we have another negative 2x squared, because those two multiply, and then negative 2 times negative 2 is plus 4x. So then we end up with x to the 4th plus 4x squared plus 4. That's how you'd square that out. Now let's say we have something kind of like this, but just a little bit different in that, so we have x squared minus 2x squared plus 3x squared. Oh no, and it says to simplify. Well, we do the same thing where we're going to FOIL this out. And one trick to foiling, if you have a square here, you can do something where, okay, so you're going to square this first one. So x squared is x to the 4th. We're going to do this times 2. So negative 2 times x squared times 2. So that's negative 4x squared, and then you just square the last one. So negative 2 squared is 4. So it's the same thing, but you get to skip a step. And you just remember you square, multiply these two together, and then multiply by 2, and then square the last one. Or you can just FOIL it normally, whatever makes you happy. Oh, but then we have to remember we still have this plus 3x squared at the end. Now we just simplify it, so we need to add our like terms, so this guy and this guy. We end up with x to the 4th minus x squared, because 3, negative 4, plus 4, and you're done. Yeah, they try and trip you up sometimes by having part of it be squared and then part of it outside. Just do the foiling first and then add the last term. If it can add. If this was x to the 3rd, it wouldn't be able to add, right? So, but it wasn't. It was x to the x squared. Okay, so let's do another one of these. So let's have f of x equals x minus 6 squared minus 36. So let's say we want to simplify this again. So you could again do x minus 6, awesome. And then you'd say, okay, that times that is x squared, and then you'd have x times negative 6, and then negative 6 times x, which is going to be negative 12x. Or you can just say x times 6 is negative 6x, times 2 is negative 12x. Either way, you get the same thing. And then you do negative 6 times negative 6, or negative 6 squared, plus 36. Oh, and we have this minus 36. So those two are going to cancel. You end up with x squared minus 12x is your simplified answer. What else can we do with this? If you're given, what I should mention is if you're ever asked to find, so let's say we're asked to find our x-intercept. And remember, that's the same thing as solving for your roots or your zeros. Zeros has an E, etc., etc., etc. They all have there's different names because different people were working on the math at the same time. It depends on if you're doing physics or blah, blah, blah. Basically, a bunch of people were doing this and not talking to each other and got stubborn, and now we call it a lot of different things. So let's say we want to find the roots of this equation. All right, so that's simple. Or else we want to find the x-intercept specifically. So when you're finding the x-intercept, you're finding a point. So x-intercept means it's going to be whatever the x is, and then a 0 for the y, because it's where y is 0. So you're going to give it as a point. So if we were to solve this, so 0 equals x squared minus 12x. I know I can simplify this by pulling out an x, so x minus 12 equals 0. Now I can again set each one of these parts equal to 0, because if you do, yeah, it's called the zero-sum theory. So I don't know if that's what's called. Anyway, zero product rule is what it's called. So if x equals 0, then 0 times this whole thing is 0. Anyway, just set them both equal to 0. X minus 12 equals 0. This you don't have to do anything else to. This becomes positive 12. So your answer is not, so your x's are 0 and 12. But that means your x-intercepts intercepts are 0, 0, because that's the x and the y, and 12, 0, because that's an x and a y. Okay, so don't let that trip you up. If you're solving after factoring, and you're solving for x, your x-intercept is going to be whatever your two things were, 12 and 0, 0, because y is going to be 0. Just one more little random tidbit to throw in. I already mentioned this a little bit earlier, but let's say we're using that same equation. Let's just do x minus 6 squared. And let's say, given this equation, find f of a plus 2 equals x minus 6 squared. So what that means is whatever you originally had here, x and x, you're going to take this and replace that x with it, because the x was replaced here, so you'll replace it here too. So it's easier in this case to put it in before you FOIL. Okay, so f of a plus 2, because you're going to replace that whole thing with x, is going to be a plus 2, because that's x, minus 6 squared. All right, cool. So that's going to be a minus 4, because these two combine, squared. And then you just FOIL that out. So a minus 4, a minus 4. So a squared minus 8a plus 16. Fabulous. That's it. That is that's it. That's what you would do in this case. You're replacing, you're substituting whatever this is for that x. So you might be asked if something is a factor of a quadratic, or even a bigger problem like x to the 4th or 5th or whatever, doesn't even matter. And the way you solve this is by doing, you could do long division, and it gets weird and complicated. It's just extra steps, or you could do synthetic division, which we've talked about before, but just to remind you, it's nice and easy. So first, solve for x in this problem. So x minus 3 equals 0, so x is 3. So now you're going to set up your synthetic division chart. So it looks like this. You put your 3 here, and then you put all of the, oh, there's another cat. Move it, move it, move it. Thank you, Scout. Oh, they love math. Then you put all of the coefficients in your little synthetic chart. And one thing to make sure is you are representing all of the polynomials, or all of the powers, sorry. So we have 2, 1, 0. So x to the 2, x to the 1, x to the 0, because it's not there. So we do have them. We don't have to fill in any zeros. So then we just put the polynomials. We put 7, negative 23, and 6. Then the first step, bring down that 7. And then you multiply these two. So 3 times 7 is 21, and you put it there. Now we're going to add these two, so you get negative 2. And then multiply these again. 3 times negative 2 is negative 6. Add these two again, and that's a 0. Which means that if, and this is your remainder, this is your constant, and this is your x. Okay, so the idea being that when you divide this by this factor, you end up with 7x minus 23 with no remainder. If this is a remainder, that means it is a factor. Okay, factor. If not, if this had been, well, we'll do another one as an example. Cat, move. Come on, Scout. Thank you, thank you, thank you. So let's do another one as an example. If we have, let's see, how about x squared minus 2x plus 3, and we want to know, we can do two things. What if you're given it this way, x plus 5? So if you can factor this, then you could cancel things out. But if you can't factor it, like this doesn't look like it's going to factor nicely. Would it factor nicely? Let's see. You could try, you would get x plus 1, x minus 3. So this definitely doesn't, you can't cancel anything out here. So it's not a factor, but you can figure out what the remainder is. So what I'm saying is, if you were, anytime you can factor out a quadratic formula, okay, so you'd end up with x plus 1, x minus 3, x minus 3 over x plus 5. Nothing cancels. So now let's find out what that remainder is. So that means this is not a factor. Factor. So let's find the remainder instead. So we're going to again solve for x. Solve for x here. So x plus 5 equals 0. X is negative 5. Then we're going to set up our synthetic division chart. Okay, again, look at your coefficients. 1, -2, +3. And so bring down my 1. -5 times 1, -5. Then that's -7. Yep, -7. -5 times -7 is +35. And that makes this 38 because we add down. Which means if you were to divide this polynomial by x plus 5, you would end up with, this is remainder, constant, x. Oi, another cat, come on. You'd end up with x minus 7, remainder 38, over x plus 5. And that's synthetic division. It also will let you know if things are factorable. Alright, so what if you have something a little bit bigger, like x to the 4th minus 5x plus 10, and you're dividing it or asking if x plus 3 is a factor? Oh no, we can't factor this at all because you have that x to the 4th. Well, we're not going to worry about it. Well, yeah, let's see. Could we factor this? If we tried, let's see. If this could be x squared and then 10. It's either 1 and 10 or 5 and 2. Neither of these things are going to add to give us -5, so this can't be factored that way. It's not an umbrella method problem. We're not going to do it. We can't use the quadratic formula either because it's not a quadratic. It is a 4th power. It's a raised to the 4th power. It's a 4th order polynomial. So instead, we're going to again try synthetic division. So we are going to solve for x on the bottom. 3 equals 0. X is -3. So we'll set up our synthetic division chart. Okay. We have a 1. Oh no, we don't. Where's x? We have to make sure we represent x to the 4th, x cubed, x squared, x, and the constant. So x to the 4th is 1. There is no x to the 3rd. That doesn't exist, so that's going to be a 0. There's no x squared, so that's going to be a 0. The x is a -5, and then the constant is a +10. So there's our synthetic division chart. So let's do this thing. So 1, bring down the 1. -3 times 1 is -3. Add these, you get -3. -3 times -3 is 9. Add them. There we go. Multiply these two. -27. Add these. -32, right? Yes. Multiply these. Something giant. 3 times 32. 3 times. Remember, when in doubt, use your calculator. 96, so +96, add them, 106. So the answer to this problem would be, so again we start here, we have remainder, constant, x, x squared, x to the 3rd, and that is, stop it Mooney, I know, math is scary for kitties. Okay, so our problem then becomes, or the answer to this problem if we were to divide it, is x cubed minus 3x squared plus 9x minus 32, remainder 106 over x plus 3. Hopefully I didn't go too fast. It's pretty easy once you get that pattern down. So this is not a factor. So if this asked is, so it could have said x, if you have x to the 4th minus 5x plus 10x, is x plus 3 a factor? Or can it be divided? The answer is no, because there's a remainder. Because there is a remainder. So it's only a factor if it divides evenly. Okay, let's take another quick look at the quadratic equation. So this, I could do umbrella method, but I'm just instead going to throw it in the quadratic equation because I'm trying to make a specific point. And also I think it's sometimes the quadratic equation is easier in weird cases. Let's remember that the quadratic equation is x equals -b. And let's make these x's instead of a's, I just noticed. Boop. -b plus or minus the square root of b squared minus 4ac all over 2a. And so if I rewrite this, I get x equals -6 plus or minus the square root of b squared, so 36, minus 4 times a, which is 8 times 5, all over 2 times 8. So let's simplify this. -6 plus or minus 36 minus 40 times 4, 160 over 16. Now, let's keep going with this. -6 plus or minus the square root of 36. Let me first make sure I didn't mess up my math because, you know, I like to do that. But it's 8 times 5, 160 36 minus 160. All right, so we get negative 124 under the radical over 16. And before we would look at this, in Algebra 1 you looked at this and you said, oh, I can't divide by a negative. Sorry, not divide. I can't take the square root of a negative number, so this clearly is not possible. But in Algebra 2 we learned that you can use imaginary numbers, and we talked a little bit about what those were, but just in brief, this means that the square root of -1 is given as I, and really it's that I squared equals -1, which is, we went into what this means, and we're just going to go with it, which means we can simplify this by saying, okay, this is -6 plus or minus, we can pull out that I, which is the negative, and 124 over 16, wait, sorry, dog's doing a weird thing, and we could simplify this radical down more, but that's not the point I'm trying to make. The point being that and we will in a second actually, so anytime you have a negative under the radical now, that's an I, and so let's simplify this down more by saying, okay, can I simplify 124, and we did this by saying, okay, I'm going to start dividing this by things that are roots, like it can be, if I have 4 and 31, that's a square root, so 2 and 2, which means if I have 124 under the radical, that's the same thing as saying 2 times 2 times 31, and since we have a pair, I can pull out 1, 2, so then this becomes 2 root 31, so then I can say, all right, over here, going back over here, I get -6 plus or minus 2i root 31 over 16, and then I can divide everything by 2. So then this becomes -3 plus or minus root 31 over 8. And that's your final answer. Oops, look what I did, I forgot the I. Boom, that's the important part. And so now we can't say that, oh, this is not possible because of that negative root. We have to instead say, oh, I'm going to pull that out as an I instead, that imaginary number. And that's all you really need to know about this for right now.